All right, we're going to take a few notes, kind of like we did on Monday. We're going to work with trig identities, and then we're going to graph. So first, we're going to do a trig identity, cosecant theta minus sine of theta over cosecant theta. So if you have one that ends up in this form, this is a good strategy to try. I call this the I love math strategy because you can make a heart out of it, and you can only make hearts right side up like this. You're not allowed to separate fractions the other way. So this heart allows me to separate the fraction. One of them is this way, cosecant of theta over cosecant theta, minus the other one is this one, sine of theta over cosecant theta. Really, now that I've got common denominators, I could add these two numerators and I would get right back to where we began. So it's just taking two fractions that have been added together with a common denominator and separating them into two separate fractions. And this is a handy strategy a lot of the time. So cosecant over cosecant is 1. And sine over cosecant, I'm going to write that as sine of theta over 1 over sine of theta. And I didn't give myself enough room, but I need to flip this over and multiply it up here. So that becomes sine of theta over 1. So instead of dividing, we'll multiply by the reciprocal. So that is 1 minus sine squared theta over 1, or we'll just drop it. That is two pieces to this identity. So you remember Monday how we were taking this identity and realizing we had two pieces and trying to rewrite it so that it equals this? So if you just move this sine squared over here, then that means cosine squared theta is 1 minus sine squared theta. So you can replace your 1 minus sine squared theta with cosine squared theta. And you are done. So that's a fun strategy you're going to get to use. That's number 1 on the worksheet you're going to get for tonight. Number 2, do I want to do that one? I think I do. It is sine squared theta over 1 plus cosine theta. Well, I'm again thinking of this Pythagorean identity. And if I wanted to replace the numerator, if I wanted to replace this sine squared, then I need to kick this over to the other side. So sine squared theta is 1 minus cosine squared theta. So I'm going to replace the numerator with 1 minus cosine squared theta over 1 plus cosine theta. And then I'm going to factor the numerator. That is just like 1 minus something squared that we would break down to 1 minus x and 1 plus x. It's a difference of squares, difference of two perfect squares. So it's going to break down to 1 minus cosine theta times 1 plus cosine theta over 1 plus cosine theta. Then this 1 plus cosine theta on the bottom and the top can divide out, and you're left with 1 minus cosine of theta. So the first few times you see one of these worked, you're going to probably be thinking, wow, that kind of makes sense, but I would have never thought to do that on my own. That is a very, very, very normal thought. And as long as what I'm doing kind of makes mathematical sense, then I say this is a win for right now. These problems can all look so very different. We're just trying to get some strategies and see some different ways to work these things. And as long as you can kind of follow how I'm using the identities, and maybe you can use these examples to help you out on the worksheets, I think that's our goal right now. So don't beat yourself up and don't stress out too much right now. We're just learning. I'm going to do number 5, I guess, on this same worksheet. I really didn't want to do 5. It's kind of similar to what you got to do the other day. I'm not going to do 5. It's similar to one that we did in class. I'm going to do 7. Okay. This is interesting looking one. This one is a verify, so I do know the answer I'm trying to get. I'm going to be working with the left-hand side to try to get the right-hand side. These are fractions that they're trying to multiply. When we multiply fractions, we just multiply numerators together and denominators together. So on the top, you're going to be multiplying like this. And on the bottom, you're going to be doing this. So on the top, we're going to distribute. And on the bottom, we're going to FOIL, or we're going to notice their conjugates and just do first times first minus last times last. If you go all the way out with your FOIL, your outer and your inner are going to cancel. Let's see. I'm going to leave the top alone for now. Whoops. And that denominator is screaming to me, hey, I'm 2 pieces of this Pythagorean identity. So it's the 1 and it's the cosine. I just want it to be 1 minus cosine squared. So I need this cosine squared to go over there. So I'll be subtracting it on both sides, or just moving it and changing its sign. So we can replace our denominator of 1 minus cosine squared with sine squared theta. And then as I'm looking at this, I've got 3 terms and they all have a sign in them. So I can take a sign away, and there's 2 signs in the bottom, so I'm going to take the exponent away. That leaves me with a 1 minus a cosine all over one of those signs that's left. When I look back to how this second line here, I probably should not have distributed the sign. If I hadn't distributed the sign, I would just have left it and not distributed it, because I didn't know any better though. And then this next line, I would not have distributed it. It would have still been over that sine squared that we got. And then if you liked that better, you could divide a sine and a sine out, and you still would have gotten the same answer. Okay. All right, time for graphing. Now we're going to graph equations that have a C. And that C, if it is the only shift that is happening in there with the X, then that is C units to the right, because that's affecting the X shift. That's a horizontal shift, just like when we were doing transformations in the beginning of the year. So if you've got y of sine x minus pi, I'm really hesitating on showing you this way. Well, I'll show you both ways, I guess. So that means I'm going to be shifting pi units to the right. So normally sine starts at 0, and normally sine ends at 2 pi. But if I'm going to shift it to the right pi units, then I'm not starting at 0 anymore. I'm starting at pi. 0 plus pi. That's my left. And my right endpoint doesn't end at 2 pi anymore. It's going to end at 2 pi plus pi. So let's see what this looks like. Nothing else has changed. My amplitude's still 1. But there's that. Okay, so there's my normal 0 to 2 pi, but we know our left endpoint isn't even going to start until pi, and we know the right endpoint won't finish, like it won't finish the curve until 3 pi. So these are the spots we're looking at. So I still have an amplitude of 1. It's just we've been shifted over. So it actually starts here at 0 at pi. At 3 pi over 2 it hits its height. 2 pi it hits the midline again. 5 pi over 2 it hits the low part. And at 3 pi it's back again at the midline. So the same curve, it just got shifted over. So I want to show it to you a different way also, because some of these problems we're going to be doing are going to have a b here other than 1. So it helps to do these two things in one step. So doing the same problem, y equals the sine of x minus, x minus pi. Is that what I said? Yeah. So we can consider something called a phase shift. And we find the phase shift by doing bx minus c and setting it equal to 0. And bx minus c and setting it equal to 2 pi. 0 and 2 pi because that's where we like to look at the curve starting and ending. And this right here, the sine of bx minus c in parentheses, that's what we're talking about, this part that's in the parentheses after the sine function, or the angle. So we can do the phase shift. So if we do bx minus c equal to 0, it'd be x minus pi equals 0. So add the pi to both sides, and you figure out that you're going to start at pi. And then x minus pi equal to 2 pi. You add the pi to both sides, and you realize you're going to be ending at 3 pi. Sometimes it is a lot easier to think of it as one big group there with the phase shift. In fact, often when you have a b other than 1, you need to look at them together. So let's do the cosine of 2x minus pi over 2. So just considering the fact that we have a phase shift here. So our phase shift is 2x minus pi over 2. So we're going to set that equal to 0 and equal to 2 pi. Add the pi over 2 over and divide by 2, or it's probably easier to multiply by a half to clear that 2. Over here, add the pi over 2 over. We're going to get really good at fractions the next couple of units. Pi over 2 plus 2 pi. Well, that's the same thing as 4 pi over 2. So that is 5 pi over 2. If that was too fast, you make 2 pi a fraction and you get a common denominator. And then instead of dividing by 2, let's multiply by a half. So you get x to be 5 pi over 4. So this graph is going to start at pi over 4. It's going to end at 5 pi over 4. And in the middle of that will be 3 pi over 4. Whoops. This is 2 pi over 4, which is pi over 2. This is 4 pi over 4, which is just pi. Remember what cosine does? Cosine starts high at that phase shift. It crosses, hits its low point, crosses, and ends high. Okay, that's it for today. You can try to work with someone if you're allowed to, and start your homework problems while it's fresh on your mind.